Okay, so you just finished the last flipped classroom on just general definitions. But what we're going to get into now is the nomenclature, what we're going to use to denote them. Okay, so when we have a point here, if I want to refer to a point A, let's say we've got a diagram of a triangle. We have point A, B, and C. Now, if I, in my proof, for whatever reason, if I need to say point A, I could just say point A, or I can refer to it as just A. Sometimes you might see something like this. I will very rarely do this. If I am referring to something, I'll either say point A or A, but I just want to get you familiar with it. Okay, so that pretty much wraps up the zero dimension. There isn't much to do in the zero dimension. It's restricted to only one point, so once you use one point, you've used up the whole space. So let's go to one dimension. Okay? So if we move to the one-dimensional shapes, we start with the line here. And if I want to refer to the line, like I said in my flipped classroom, it's good enough to just say AB. But if we're writing this down, it's important that you write it like this. Notice I have two arrows here and the 2 points here for line AB. If I just throw in another point here, C, it turns out that this is going to be the exact same if I do this. I don't really care the order in which you do things when it comes to lines. They're all fine, except any of those things, because as it turns out, we'll talk about it in class, but really all you need is 2 points to determine the line. Now, I get the question every year, what if you do something like this, A, C, B, okay, in order? You don't need that, and really we don't do that in math because you don't need 3 points from the line. We want to keep it as minimal as possible, especially when we're writing, 10-step proofs. Just that extra letter every time is not going to be very helpful. Okay, so these are lines here. What about rays? I talked about this a little bit in the class, in the flipped classroom. You have to make sure that you're going in the direction, get your starting point and going in the direction of where you would like to go. So, for example, ray AB, and again, you notice I have this denoted there in the direction of which it's going. So let me see if I can find another color. So ray AB is basically this guy. Okay, it starts at A and goes in the direction of B. Now, if I said BA, again, I'm going to write it like this. That's going to be this ray right here. Okay. Again, another question is, can we write it like this? No, not really. We don't really like that because we like to read it in the direction that we're going. Okay, so I say, oh, we're starting at A and going in the direction of B, or we're starting at B and going in the direction of A. If I did this, then I'm saying, okay, A is where we're going and B is where we're going to start. It doesn't really make as much sense. Again, little things, but I just want to get us all on the same page here. Okay, we want to use the same language when we write and sketch these things out, just to make things easier on all of us. Okay. Finally, we can talk about segments. Have to start and end with the points, okay? So if I want to talk about the segment AB, that's fine. Notice I don't have any arrows on this one because there are no arrows on segments. Starts at A, goes to B. Another acceptable one is from B to A. Start at B, go to A. That's the exact same segment. Okay, so really rays are the only ones that you have to kind of keep an eye out for. Okay, that these two are not going to be the exact same ray, but these two are going to be the same segment, and these three are really going to be all the same line. Okay, that's just the congruency symbol. Don't worry about that too much. We'll get to that in a bit. Let's see. Okay, moving on to 2D now. We've got our plane here, which again is just symbolic here. Technically, these planes go off in all directions here. Okay, but we'll just kind of keep it as this, little trapezoid thing that looks like a flat square. Okay, seen a couple of different ways to denote this. if you have, let's say, that little fancy C in the corner, like in my video here, we could say that this is plane C. I've seen this, although I don't really like that at all because that's going to, there's just a lot that goes on there. Are we talking about a trapezoid? Are we talking about a plane? I really don't like this one. If we had a few points in the plane, then this would be acceptable. If you had A, B, C, I'll accept that one because if I had a third point, E here, then we have confusion as to whether I'm referring to a quadrilateral or if I'm referring to the plane. So if you have 3 points, very important, not in a line, 3 points that are not in a line, you can use this notation right here. Again, plane C is probably the safest bet, and I don't know how many times we're going to be writing these things, but it's just good to get it all on the same page here. Okay, next we've got the angle. I think I made this pretty clear in my flip classroom, but in case we need to know how to write it, I use that symbol for angle. Sometimes you see it like this in books. Don't like that just because it looks like less than, especially if we talk about the measure of an angle. It looks like I'm saying M is less than B. So just get in the habit of doing that little symbol right there. It's pretty straightforward. A, B, C. B, that middle point has to be the vertex. Has to be the vertex. Has to be. Okay? Don't know how many times I have to repeat that. Okay? Because if I'm going to write this right here, BAC, I'm going to be referring to this guy. BAC is this angle right here. Okay? We don't want that in this particular diagram. Okay? So keep that in mind. All right. Moving on. The other thing is you can refer to it, if there's absolutely no ambiguity, you can refer to it as a single letter. Okay, so if I'm talking about triangle, A, B, C. Okay, if I say angle B, you know exactly which one I'm talking about. But if I just make one slight adjustment here, okay, then if I say angle B, you don't know what I'm talking about. Okay, so make sure there's no ambiguity if you're going to use this shortcut. I'll use that shortcut at some point, but at the beginning stages, don't do it. Don't do it at all. So now we move on to relations. These are the symbols that we use for at least the starting relations that we have, okay? This guy right here, probably recognize, perpendicular. Okay? We don't need to define that right now, but at least be familiar with it. It's an upside down T. This next one means congruent. Okay? Same shape, same size. Okay, we can say that two lines are congruent. All lines are congruent, really, but two triangles are congruent. Two parallelograms are congruent. So that's what we have as a shortcut notation. This means parallel. And as we talked about in the last classroom, you could have two lines being parallel. You could have two planes being parallel, but we use the symbol of two, looks like two lines being parallel to kind of keep that in mind. There are no symbols for skew. We just say that the two lines, M and N, let's say, are skew. Trying to think if there's anything else. All right, so let's just do a quick example of how we might write some of these statements. So let's say I have this angle right here. And I'll do this sometimes. I'll kind of sketch that little angle in here just to kind of denote which one it is. I'll also do this. Now, I put a hatch in this one and not in this angle, just so that you know that they're clear. It's clear that these are not going to be the same. Now, if I do this, then what that means is it might not look like it, but I want these two guys to be congruent. Okay, so if you see that they have the same little hatch mark on it, they are assumed to be the same size. Okay, so let's write a statement here. So I want to say that these two angles are congruent. Mathematically, we have to first name this one, name that one, and then make sure it's spelled correctly, okay? So, can we say that angle B is congruent to angle E? Well, no, this is exactly what I was talking about. You can't say that because you don't know to which ones I'm referring, okay? E is the point in the dead center of this whole intersection. There's a lot of stuff going on there. So let's be a little bit more specific. So maybe we could say angle AEC. I like to sketch these out with my finger when I spell them out. So if I say, okay, angle AEC. See what I'm doing? As I'm saying it, I'm going from that point to the next point. Okay, so angle AEC. Back up a little bit. That guy and, let's see, angle DEB. Those guys are congruent. So that's how we would write that statement there. We have angle AEC is congruent to angle DEB. Hopefully that makes sense.